Alright, so the question says, describe the error in graphing f of x from each function, then graph the function correctly. Number 2 says f of x is x times quantity x minus 2 cubed. So here's the graph. So what I like to do is I actually like to graph it correctly first, then I can compare, and then I can describe. So the first thing I'm going to do is recognize that in graphing this, this is x to the first power. Now when you see exponents, that word you should have thought about is multiplicity. What word, class?
Multiplicity.
What does multiplicity refer to? Multiplicity refers to when they're in parentheses, or you have a monomial, they call it, just a variable by itself. It's just the number above. Well, what does that mean? The quick way of just getting what kind of polynomial is it is just x to the first. This one you would expand x minus 2 times x minus 2 and do the box, and you have this really big box and you multiply by x minus 2 again. Or you can just do this really quick shortcut, is recognize that your answer is just going to be cubic, x to the third. So your answer is x to the first plus 3 gives me x to the fourth. Class, when it's x to the fourth, this is what? How would you describe this polynomial? It's a quartic. Is this quartic function even or odd? If it's an even degree. We know that the easiest even degree is probably y equals x squared. So I'm going to start up, end up. I recognize that my leading coefficient, the number in front, there is no negative. So my leading coefficient is just a positive. A is equal to 1. Some other clues I can get. Because you're multiplying here, I can apply something called the zero product rule. So x equals to 0. So you can write that zero product rule. What is the zero product rule? It's essentially setting this equal to 0. Caesar, go outside, please. And after you set each of those equal to 0, now notice how I'm not really going to, well, I'll make it obvious to you. You're essentially writing this x minus 2 how many times? 3 times. So here's 1 0. Notice how it's an odd. In the word multiplicity, if it's an odd, what do we associate with? What's that real practical word? It's a shoot through. Now if I solve these, I only have to solve it once because they're exactly the same. If I add 2 to both sides, x is equal to what? 2. Well, essentially all of these are x equals 2, right? And I'll show you guys why it's not repeated. But if you look at the problem, my multiplicity is what? Odd or even? Odd. 3 is an odd. Kiss or shoot through? Shoot through. So when I graph this, let's put an x-axis to this. So here is x equals 0. Look, if I graphed x equals 2 3 times, 1, 2, 3. It's just in the same spot 3 times. Does that make sense? I call that a triple group. Now there, I'm also going to be an odd, and we're going to just shoot through it. So we already know I'm going to start up. Use the pencil just in case I make a mistake. And I'm going to end up. So I'm going to have to go through here, do some kind of squiggly, and then back up. And the reason why I did a squiggly, and I didn't just do it, because I can't do a quadratic, because quadratic means that I have maximum 2 x-intercepts, and then class, what's 2 minus 1? one turning point, but this is quartic. So count the turning points with me, or count the maximum and minimums. Those are called extremas. Count with me. Ready, set, go.
1, 2, 3.
That's essentially the number of extremas, maximum and minimums. It's this number minus 1. Okay? So now if I compare this to the graph they gave me, what's the error in this graph? They graphed an odd. The wrong graph is an odd degree. Well, what's wrong with it? Its end behavior, starts down, ends up, is incorrect. The end behavior is incorrect. Notice here you do have a shoot through at 2. They did not graph the x-intercept, x equals 0. Didn't graph x-intercept of x equals 0. And basically here we have a quartic, but here they have a cubic. So odd degree or cubic. The wrong graph. So I gave 3 reasons. You don't need to have that many, but you should be able to recognize why that graph